Hi everyone, welcome back to your channel Clarity for Sure and welcome to yet another series of ARD static revision. So today we'll be covering few topics from farm mechanization. Let's see what are the topics today's session holds. So these are all the topics. So today we'll be discussing one by one all the topics mentioned here, right? So let's see the first topic. First, let's see what is the meaning and scope of farm mechanization. So generally the farm mechanization means you are using all the powers available like mechanical, electrical, renewable, hydraulic power to carry out more efficient agricultural operations, isn't it? Then it includes the tractors, power tillers, threshers, harvesters, irrigation pumps, and all the post-harvest machines. So why there was need for mechanization in India? Because there were rising cost and scarcity of labor. Okay, there was ongoing small and fragmentation of land holdings. So that small or fragmented land holding require efficient small scale machine to tackle the agricultural operations. Then there was need of increasing the productivity per unit area to reduce the drudgery and to improve the timeliness of the operations and to enhance or to be very precise and uh, precise in usage of the inputs so as to reduce the input wastage, like inputs include the fertilizer, seeds, pesticides and all. Okay, so here are the extent of mechanization as per ICR, how much level or how much percentage particular operation have a mechanization level. Okay, so here you can see the maximum level of mechanization holds for the seed bed preparation, whereas up to near about same similar 31 to 32% holds for the weeding and interculture and harvesting and threshing processes. Okay, so according to ICR also there was they have quoted that there is highest mechanization available for wheat cultivation, then lowest in rice transplanting and sugarcane. Okay, and whereas the India holds the largest position in tractor market. Okay, so here are the advantages. I have again repeated here, like the mechanization help in enhancing the productivity, they reduce the labor drudgery, they help in timely operations, they also aid in post harvest, reducing the post harvest losses. They aided in the more input use efficiency. Okay, then there was improved soil and water management because of mechanization, and ultimately the economic benefits like lower cost per hectare and promoting the entrepreneurship. Okay, so these were all the advantages of mechanization. Let's see the power sources which are used under mechanization. So the power sources are like human, animal, mechanical, electrical, and renewable. In the human power, it is still predominant and generally used by small and marginal farmers. Like they have power output of zero point 0.1 HP per person, which is sustained, which is very sustainable, or we can say which can be done. Which can be useful for certain farm works. Okay, and the operations which can be done using such power output are like sowing, weeding, harvesting, spraying, irrigations. But the limitations are also there because they causes fatigue, they have low efficiency, they causes seasonal scarcity also. Okay, so that is why the mechanization here will reduce the physical drudgery and increases the output of the farmers, as you can see in the images how farmer is doing all the works by himself. Okay, then we have animal power. The draft animals, like in some areas, bullocks, camels, horses, buffaloes, these are all used for tillage and transport purpose. And the output per pair of the bullocks gives about 1 HP. Okay. And the draft capacity, these are very important figures. Okay. These are very important. Please make note of it for your NABARD examination also. NABARD examination and other agriculture examination also. So the draft capacity here is about 1/10 of the body weight of the animal. Okay, and the common implements used here are wooden and iron plugs, harrows and carts. Okay, still it is very important in rain-fed, hilly and smallholder farmer areas, and the limited limitation is generally related to the animals, like the availability of the feed. Okay, the lower speed of the animals, the efficiency compared to engines are very low. Okay, then we have mechanical power and farm mechanization. They are generally derived from the IC engines, or you can say internal combustion engines, where we are using diesel or petrol. So the power tractors, power tillers, threshers, pumps, and combine harvesters are generally used for generally are used for as a mechanical power sources. And talking about the efficiency of diesel and petrol engine, you can say that there is 32 to 38%, again very important data, and petrol have 25 to 32% efficiency. Okay. According to mechanical power, the advantages it holds, it's that it gives higher power, reliability, speed, and continuous operation ongoing, and it is very suitable for large holding and heavy task operations. Whereas the disadvantage, you can see that there is very high initial and maintenance cost. There is also instances of environmental pollution because of these power usage. The dependence on fossil fuels are also increasing because of these sources. Okay, so these all have stated that the trend, it has depicted the trend that over 40 to 45% of Indian farmer power generally made by the mechanical sources. Okay, nearly half the percent of the Indian farm power are generally its demand is met by the mechanical source. Okay, then we have electrical power. These are generally used in pumping the water, in dairy processing, cold storage, feed grinding, lighting, and fruit handling. Okay, so the advantages are very clear here. Like they are clean, cheap, efficient, and very versatile in nature. They allow automation and continuous power supply. Okay, but the dependence on rural electrification network is one of the causes of its low usage, and the grid or solar-based power pumps can be used to achieve the electrical power operations. Okay, so these were all the things about electrical power. Then we have wind power. Okay, it converts the kinetic energy of moving air into mechanical or electrical energy. So India has potential of 695 gigawatts and installed capacity of 38.26 gigawatt and manufacturing capacity of 10 gigawatt per year. These two data are very important. Okay, and next data, the fourth, India ranks fourth globally in wind capacity. Okay, the major states are Tamil Nadu, Gujarat, Maharashtra, Karnataka, and Rajasthan. Okay, whereas this largest wind farm is situated in the Tamil Nadu, Mupandal Wind Farm. Okay, which is the largest in India. And next we have NIWV in Chennai, which is the National Institute of Wind Energy, situated in Chennai, and which is the nodal for research and development and technical agency. Okay, and where we use generally these wind power for water pumping, electricity generation, hybrid wind, solar systems. Okay, next we have solar power, which converts the sunlight into electricity using the voltaic cells or into heat for drying and cooking. Okay, the target for renewable energy target according to India is 500 gigawatts on non-fossil capacity by the year 2030. Again, very important. And as of this year, January month, we have installed 217.62 gigawatt of solar power, and we have potential of 748 gigawatt. Okay, and what are the global rankings? As per the solar power, we have fourth in global renewable capacity, we have fifth in solar capacity, and fourth in wind installation. So these data are again very important for NABARD exam. Okay. Let's see what are the major solar parks. First, we have Bhadla in Rajasthan, world's largest. Okay, then we have Kutch Hybrid Renewable Energy Park in Gujarat, and we have Shakti Sthala in Karnataka. Okay, so these three are very important. Just have a glance over them. Okay, then we have, let's see what are the applications of solar energy here. The solar pumps, dryers, fences, milk chillers, lightning, greenhouses, all these areas are where these solar energies are very prominent or have a very potential usage. Next, we have OSOWOG, which is a global initiative. It is known by One Sun, One World, and One Grid. This is a global initiative which was it was launched during International Solar Alliance in the year 2018 during the COP 26 2021 session for sharing the solar energy across the regions, right? Next, we have biomass energy, which is, as the name suggests, we are converting or getting energy from organic matter like crop residues, wood chips, agro-industrial waste, dung. Okay, as you can see, here are all the agro waste which are going into this industry, or you can say plant, and it is then converted into energy. Okay, so in India, it is around 32% of total primary energy source. Okay, and more than 70% of people generally depend on this source or this energy. Okay, so they are very of renewable nature, carbon neutral, and decentralize the energy sources. So far, we have a potential of 10 gigawatt, and the biomass gasifiers, biogas plants used in rural area for heating, lighting, irrigations are one of the prominent sources to recover the biomass energy. Okay. Next, we have biofuels. These are very important, and this table is very, very, very important. Okay, biofuels are liquid or gaseous fuels which are derived from the biomass for transport and power generation. So we have four generations here. So these the generations and the feedstock or source use are very important. Many exams, very I mean you can say many examples are there, many instances are there that these questions regarding the biofuels generations are asked. Okay, so the first generation includes the sources of food sources like sugarcane, maize, and oilseed. They are very of simple tech. Okay, but still it requires continuous food supply to generate first generation fuel. Okay, next we have second generation in which we use agri waste, bamboo, husk, wood chips. They have uses, they are used as non-food biomass, and they have low GHG or greenhouse gases. Then third is algae and aquatic biomass are used as feedstock. They have higher yield per acre, and they are very of sustainable nature. Okay, and the last fourth generation is engineered fuels with carbon capture and storage. They are carbon negative, and they are of futuristic nature. Okay, let's see few Indian initiatives targeting the biofuels. First, we have National Biofuel Policy 2018, under which we had targeted of blending the ethanol in petrol of 20% to achieve it by 2025. Then we have 2G biorefineries for ethanol from agri residues and promotion of biodiesel from non-edible oils. Okay, so this was all about the biofuels. Now we are heading on to implements. Okay, tillage implements. So first is primary tillage. Here you have to remember the primary tillage, its examples, and then secondary tillage and its examples. That's it. And I'll be explaining in detail all about the implements. So take note of everything I'll be explaining here. Okay. So first we have indigenous or country plug. Okay. It is a traditional animally drawn plug used for shallow tillage, opening the furrows and breaking topsoil. It generally forms V-shaped furrows while doing its operation, and there are generally the draft source is bullocks. Sometimes in some areas camels are also used. The working depth is very important, very important. Okay, very, very important. Mark 3 star, 4 star here, because all the implements working depth, their angles, these are very important. Okay, so please make a separate chart of these all depths. Okay, the function is that they help in breaking the soil crust, uprooting the small weeds, making the furrows for sowing. Okay, and there are different parts of it, like beam, which is a long wooden pole connecting the plug body to yoke and have an angle adjustment to control the depth. Then we have body, which is mainly made up of wooden or steel block holding the shoe and chair. The chair is the cast iron or forged steel, which is a narrow and pointed, which has a width of 15 to 20 centimeter, and it is generally aiding in cutting the soil horizontally. Okay. Next, we have shoe, which supports the shear and controls working depth. They are of usually L-shaped. Okay, this is it. Then we have handle, again single wooden handle, as you can see in the image, single wooden handle which is used to guide and balance the plug. The advantage is that it is of low cost, easy maintenance, and useful for small feeds. Okay, the limitation is that it has very low field capacity of zero point 0.3 to 0.4 hectare of 8 hours. This is very important. Okay, and it gives only shallow soil disturbance. So as you can see in the image, how the indigenous or country plug is seen. Okay, next we have mold board plug. Okay, it is a soil inverting plug that cuts, lifts, and pulverizes the soil slices for primary tillage. And the sources are they are can be tractor they can be attached to tractor, or they can be used with the help of pair of bullocks. Okay, and the working depth, again very important, 15 to 25 centimeter. The steel used are high carbon steel, or you can say the cast iron. Okay, or high carbon steel or chilled alloy steel or cast iron for wear resistance. Okay, so this is how the mold board is seen in slide curve shape. Okay, then let's see what are the major four operations performed by mold block. They have cutting. They help in cutting the colder part of the MB plug and the share part. They are the one which help in cutting the soil horizontally and vertically. Then the lifting part is done by the frog and lower mold plug which lift the soil slab. Okay, and then we are seeing that it is also helping in inverting the soil. It slides the upside down the soil part to bury the stubble and the weeds, and it also aid in pulverizing by breaking the soil further while sliding over the curved mold board region. Okay, the different suctions are also important, like they have vertical suction of around 5 which controls the soil depth penetration of the MB plug, and it has very higher plug, so it leads to very deeper plugging. Then horizontal suction is of around 3 to 5 again very important. It provides a side clearance and reduces the friction. Okay, after the plug is moving, the soils are generally throw the soil side by side. Okay, so this side by side clearance is known by horizontal section. Okay, so it helps in improving the soil inversion. Next, we have major parts like the shear, which helps in cutting the soil horizontally, the coulter, which cuts the soil vertically ahead of the shear. Okay, so this is very clear. The shear part helps in cutting the soil horizontally, while coulter helps in cutting the soil vertically. Then mold board is the main part which lifts the inverts and pulverizes the soil slice. Then we have frog, which is which it help in or we can say it is a foundation which is holding the share and MB. Okay, next we have land side, as you can see in the image. Okay, let me zoom in further. Okay, next, we have land side, which balances the side pressure and keeps the plug straight. Okay, then we have tail piece, which gives the finishing shape to the turned soil. The gauge wheel, which maintains the uniform plugging depth, and jointer, which turns the top soil more completely for better burial. Okay, so as you can see, the frog is here to which the MB or mold plug and share is joined. Okay, these are the frogs. Okay, these are the frogs. So this is all about it. This image is very important. Okay. Next, we have types of mold plugs. Okay, so there are generally four types. First is for general purpose, which is of medium curvature, used for typical farm conditions. Then we have cylindrical, which is important for when we want strong soil pulverization. There is also shallow turning, and it is very suited for dry and hard soil. Again, very important. Then we have sod, and also the cylindrical are generally not used for on the land which are very well covered with grasses. Okay, and when there is very and when there is a land which is fully covered with grassland, we go for sod or grassland MB, okay, which is a long, gentle curvature, and it is used for pasture and turf inversion. Okay, then we have scotch or semi-digger MB, which is a slate type, also known by slate type MB. It is helping in deep penetration and completing the inversion, and it is preferred in clay soil or black soil or sticky soil, you can say. Okay, apart from clay soil, there is also sometimes instances that they ask you about which of the following type of MB plug is used on sticky soil. So then also scotch or semi-digger MB is one of it will be correct answer there. Okay, then there are different types of share, like slip share, which is the cheapest and easy to replace and sharpen and most common and mostly used by farmers. Share is this. Then we have bar point share, the narrow tip for hard soil penetration, higher durability. Then we have shin type, which is a longer cutting edge for abrasive soils. Okay. Then there are different types of plug accessories, which can be attached or detached from the plug. Okay. First, we have gauge wheel, which controls and stabilizes the depth, or you can say it helps in uniformity of depth. Okay. Then we have coulter or knife. It can be of knife type or it can be of disc type. It reduces the draft by better cutting of the soil, or also or it also be useful in cutting the trashes and burying it under the soil. Okay. Then we have jointer, which improves the weed and trash burial, and it also resembles like a miniature plug. Okay. Then we have tail wheel, which prevents the sidewise movement. Okay. So these were all about the things about MB plug or mold plug. Next, we have disc plug. Okay, very important primary tillage, which is the plug that uses the concave steel disc, as you can see in the image. Yes, concave steel disc to cut and turn the soil, and it is ideal in hardy, stony, or root heavy soils. Okay, the working depth 30 to 40 centimeter is very important. Disc diameter again very important. Please make note of it. The number of disc, like how many disc is generally kept, is 2 to 6 depending on the size and draft capacity. Like these are discs, no. So how many you can keep, it depends upon the size and draft capacity. The material used, or we can say the disc material, is generally they are heat treated alloy steel with high carbon content. Okay, so because these steels, these kind of steels have very less wear and tear. Okay. Next, we have the angle adjustment. So these are very important. So in the comments, please let me know which of these two angles is related to, I mean, out of these two, one is related to when the angle is inclined to uh, travel of the travel of the soil or travel of the equipment. Okay. And next is when the angle is inclined to vertical plane. So uh, according to these key terms, you will be able to define which is resembling the disk angle and which is resembling the tilt angle. Okay. So the disk angle is ranges from 42 to 45 degrees Celsius, and the tilt angle ranges from 15 to 25 degrees Celsius. Sorry, 42 to 45 degree. I'm sorry, degree. Okay, 40 to 45 degree, and tilt angle, which is 15 to 25 degree. Okay, so sorry. So it is like the disc angle, it controls the soil penetration and aggressiveness of the cut, whereas the tilt angle, it controls the soil throw and lateral movement. Okay. Next, we have gag angle. Again, it is adjusts the working cap efficiency and polarization depth. So these were all about it. Please comment your answer. Which angle is, I mean, which angle represents the inclining of disc to the distance travel or the direction of the travel, and which angle inclines to vertical plane. Okay, so this is very important. Okay, the disc angle 42 to 45 degree, and tilt angle for 15 to 25 degree. Most of the exams, the favorite question generally, or you can say the question are generally curated from this only. Okay, so please make a note of it. Next, we have major parts, the frame part. So the frame is related to, it supports the disc gangs and it the linkage. Okay, then we have concave disc. The concave disc is, they are defined by their concavity. Okay, so that is why the disc are I mean, the disc are generally, you can say the disc are judged based on their performance on, or you can say measurement of their concavity. Okay, so the concave disc here is, it helps in cutting and turning the soil sideways. Then we have gang axle, which is holding the disc in a series. Then we have scrapers, which remove the stuck soil from the disc surface. Then the bearings, as you can see, if you are familiar with these kind of bearings, like small balls. Sorry, the image is not clear. I'll draw one again. The bearings are generally, if you have seen these kind of bearings in motorcycle or bicycles, right? Circular balls are there. Okay, so these are bearings. It allows in smooth frictionless rotation. Okay, then we have furrow or gauge wheel, which controls the working depth and alignment. So these were all the major parts of uh, the disc plug. Okay, so again, I am saying these angles are very important. Please make or not, please make note of it, and please let me know in the comments about the definitions about these two angles. Okay. And please, so I'm again saying sorry. I was just in the flow. I was got confused with the degree here. Okay. So next we have chisel plug. The definition here is, it is the deep working plug which is designed to break the subsurface hard pan without the soil. Okay, soil inversion, and that is that. minimum it is 30 to 45 centimeter, and maximum it goes up to 60 to 70. Mostly they have, as far as remember, most of the questions according to these chisel plugs are asked on this higher value. Okay, so please make note of it. Next we have tines. What is tines here? These are tines. Okay, you are seeing this, these are tines here. Okay, so the number of tines generally they have 3 to 7 heavy shanks, or the spacing is generally 25 to 40 centimeter, uh, 25 to 40 centimeter between each tines. Okay, and the draft power of these plugs are 35 to 60. Then we have advantages of this plug is that they maintain the soil structure, improve the internal drainage, enhances the soil penetration, and so on. Then we have uses that they have reclaimed land. Uh, they have helped in reclaiming the lands, dry lands, and soil compacted with repeated tractor uses. So these was all about it. Next we have subsoil plug. Okay, so the it is a tillage implement which is used for shattering the hard pans below the normal soil cultivation zone. And very important, very important working depth of this plug is 45 to 100, one of the highest. Okay, then we have the shank design. It is parabolic, straight, and curved due because of heavy duty beam. And the power requirement is not important here. The working depth is very important. Okay, and applications again. It is generally used in the areas of cotton belt, black soils, clay soils, and severe subsoil compaction. And the benefit it provides that it improves the water infiltration, reduces the runoff, and increases the root depth, enhances moisture storage conditions. Okay, so these were all about subsoil. And you can see how the subsoil plug is seen. Okay. Next, we are moving further to secondary tillage implements. So here the harrow, the levelers, these are cultivators. These are the secondary tillage implements. Okay. So first we'll be discussing the disc harrow. Okay. So disc harrows are the secondary tillage which helps in breaking the soil, mixing the residues, and preparing fine seed bed. Okay. And the disc type it holds is they are sometimes of plain or notched concave steel disc. Okay, the disc diameter again very important, 40 to 60 centimeter. Very important question can be formulated from here also. Okay, next the suitable soil on which these plugs are used are hard lumps, crop residues, conditions where the spike harrows fail. So in this way, the let me zoom out a little. Okay. So in this way, the disc harrow is seen. Okay. The different types of disc harrow, we have single action disc harrow, double action disc harrow, which is also known by tandem disc harrow. Then we have offset disc harrow. Okay. When the disc, if we talk about the single disc, when this disc is moving in the one direction. Okay. So what happens? It requires multiple pass because at one go it doesn't cut the soil more efficiently. So that is why it requires multiple pass. In the double action disc harrow, what happens? The first front harrow, it will throw the soil outward. Okay, and the second or we can say the innermost harrow disc harrow will throw the soil it's up in its opposite direction. So in this way, in one go, the soil is polarized twice. So it is one of the best action disc harrow which can be used while using the secondary implements. Okay. So next we have offset disc harrow. So in this, what happens? The first disc harrow part will throw the soil in its left, and this will throw the soil in its to its right. So in this way, this will also help in depolarization. But there are also instances which will this will require multiple passes. Okay, so one of the most efficient action disc harrow is double action here. Okay. Then we have major parts of disc harrow like the frame. It's supposed the disc gangs, the disc it cuts and pulverizes the soil. The gang bolt and spacing it determine the penetration and aggressiveness. The bearings we have said earlier helps in the frictionless disc rotation. Okay. Then scrapers, which clean the soil structure, this curvature. Then hitch points, which connect the tractor for draft. Okay. So it is very important. You can expect terminology questions also from here. Okay. Okay. Next we have spike tooth harrow. Okay. Let's see the image how the spike tooth harrow, as you can see in this way, the spike tooth harrow is seen. So the spike tooth harrow is light harrow with iron spikes used for shallow cultivation, and it is used for clod breaking, leveling, harrowing after after sowing for covering, so pulverizing. Okay. Next we have spring tooth harrow, which is also known by Bermuda grass eradicator or quack grass eradicator. Okay. So in which the teeth is kind of curved. I mean, you can see in the image how the spike is slightly curved, right? They are slightly curved. So these are known by spring tooth harrow. Okay. So they are curved spring steel that deflects when hitting the soil or stumps, and they are generally used as secondary tillage in stony or rough terrains. Then we have SME harrow, which have, as you can see, these are SME. Okay. Yes, so it is the design of this harrow is that they form zigzag pattern of the sharp blades, and they are generally animal drawn, and it is also known by blade or curved knife tooth harrow. Okay, and the function is that it is used in fine soil pulverization and seedbed finishing, and used in sandy and loamy soils. So these were all about it. Next we have patella, which is a leveler harrow. As you can see in the image, it is a wooden plank with mild steel blade edge, and it helps in field leveling and smoothing after the tillage. And generally, they are animal drawn, used after plugging. Okay. Then we have triangular harrow. As you can see, it is of V-shaped frame with spike or blade teeth, and has a function of clod breaking and fine leveling. Okay. Next we have blade harrow, which is bhakar, which has a design of flat, mild steel blade, which with the 8 to 36 inches wide, and they have function of weeding, shallow tillage, and black soil cultivation, widely used in central India where the black soil is seen. Okay. Next, we have power harrow. They have a power source of PTO, and they generate, that means they are tractor driven. The working principle is that they are vertically rotating and produce fine uniform tilth, and generally used in vegetable or horticultural related belts and commercial cropping areas. Okay. Next, we have rotatory tiller or rotavator. So again, it is one of the important, very important, most of the time questions from the secondary implements. Rotavator is a very favorite question of examiner. Okay. So the function is that they break the soil, pulverize the soil, mixes them the residues, and prepares the fine seed bed in single operation. Okay, at a single run, thus saving time, fuel, and cost. Okay, and they are generally operated through PTO shaft, having they are attached to 3-point linkage and have a RPM of 180 to 200 RPM. Okay, so this is what was asked in A4 also. Okay, so you can see how much the power source of rotavator is important here. The working depth again 8 to 20 centimeter, which is adjustable, very important again. The field capacity is ranges, but let it be. Next, let's see the suitability of this equipment. They are generally suited for upland field preparation, incorporating green manure, sugar and trash, vegetable fields, horticulture beds, seed preparation for cereals and pulses. An advantage is that they replace the plug, and they can aid in 2 to 3 harrow operations. They save 20 to 30% fuel, gives uniform soil teeth, and mixes the crop residues, organic matter thoroughly, and increases the soil pulverization and root aeration also. Okay. So the limitation is that there is very high wear and tear of blades. The high energy demand increases where the soil is very dry and hard. Okay. And it also leads to damaging the soil structure if overused. Okay, so this you can see how the rotavator is seen. Okay, the blades are kind of like in this pattern. Okay, so based on the blades, there are different types like L type blade, C type blade, J type blade, then straight blade. Okay, let's just see the characteristics and suitability. So the L type is generally used for strong or heavy duty. The C type is generally used for lower power or when you require very smooth cutting angle, then J type is used in thin soil profile with enables deeper entry with reduced resistance problem. Okay. Then we have straight blade, which is simple flat cutting surface. Okay. And the suitability you can read from here. Now let's see the rice puddling implements. Okay, the first is cage. The first image is cage and second is puddler. Okay, the first you can see the cage, most commonly used. It provides high traction and provides prevents a slippage in wet paddy fields during puddling, and it is a steel circular rims fitted with lugs, blades, or bars, allowing better grip. It is of 1 mm width. Okay, so these are of 1 mm width. Then we have fitting. It replaces the standard rubber wheels of tractor and or power tiller, as you have seen many areas how these are used. The advantages are better tractive efficiency, reduced wheel slip, improve the soil churning process, and essential for wetland paddy areas. Okay, the weight is not important for cage wheel. The weight is important for this rice puddler. Okay, so let's see about the puddler. It the function is as it is simple. It churns and mixes the wet soil, reduces the percolation losses, retains water in the paddy field, facilitates easy transplanting. Okay, and it is suitable for wetland paddy field preparation and after plugging. So there are different blades of puddlers, like blade puddlers, rotatory puddlers, comb type puddlers. Okay, so these puddler has different functions. Like blade puddlers have, they are simple blades which rotate through waterlogged soil. The rotatory puddlers, they rotate blades powered by PTO engine. The comb type puddlers, they comb blades for finer soil mixing. Okay, the advantages you can see, they are generally simple, as same as the gauge wheel. The important thing is here the weight of this puddler. Okay, the 30 to 40 kg and 5 to 10 centimeter of depth. Okay, so these are very important. Next, let's see the intercultural farm implements. We have hand hoe, which is kurpa. The operation is, they are generally manually operated, commonly used in India, especially by women workers. And they have different uses like weeding, loosening the topsoil, soil aeration, breaking the crust, and removing the volunteer plants. The advantage is very simple: cheap, high accuracy in row crops used in small plots, kitchen, gardens, vegetable. As you can see, this is the kurpa. And limitation is that very labor intensive and very slow in large fields. And this is hoe cum rake. Okay. So it is a blade for cutting the soil, and rear sake for collecting the weed. So from here you cut the soil, and from here you rear the rake for collecting the weed residue and trash. Okay. Then we have uses of as that there is use of weeding, soil loosening, clod breaking, and collecting the straw and weeds and residues. The suitable area for using this equipment is that, or implement is that, suitable for garden, fruit orchards, vegetable farms, nurseries, and home farming. Next, we have long handle weeders. Okay, there are different types of long handle weeders. We have star type weeders and peg type weeders. The star type weeders includes the star. They have, as you can see in the image, they have star type of wheels. Okay, so these are generally disc which rotates over the soil to uproot the weeds. The power source is manual push or pull type and reduces the bending stress. And next we have peg. Apart, like if the peg type, like these are kind of in this way, the peg weeders are generally seen, as you can see in the image. Okay. So these are generally pegged cylindrical drum rolls through the soil, removing weeds, and it is best used in paddy fields and moist soil where the pegs get better drip. Advantages is that they increases the output with minimal farmer fatigue. Okay. Next we have wheel hoe, which is this, and it is has a design of one or two wheels, interchangeable tools, sweeps, blades, tines. Okay, and the operation is manual but easier and faster than hand hoe. And uses is that it can be used between rows, soil aeration, and gives lighter tillage. And advantages, it reduces the labor fatigue and increases the working speed. Okay, next we have cultivators. This is the image of cultivator. So cultivator, we have they have the function of soil stirring, weed control, between rows and breaking clods and soil aeration. And the depth is again important here, 8 to 15 centimeter. And the field capacities, you can see there from here, like zero point 0.2 and 0.20 to 1.2 hectare per hour, depending on the size and power and all. And the different types of cultivators, ridge tine, spring tine, duckfoot tine. Just have a glance over the names. That's it, nothing important. Okay. So that was it. In the next part, we'll be discussing major water harvesting structures in detail. So thank you. Let's meet in the next part.